Alright guys, so it's time to start on chapter 8 for statistics. Now for you seniors, we're not going to get all the way through the chapter, but at least you'll have an idea of what hypothesis testing is and a couple of little basic things with and doing a little bit of hypothesis testing. And as far as the rest of you, we'll definitely get through this, and we're going to just keep on moving as we go along. So anyway, the thing that I want to do today is I want to just give you a setup for hypothesis testing. I want to give you the idea and deal with a couple of really important vocabulary terms. Okay, so what is hypothesis testing? So basically, we're going to do a little talk about hypothesis testing. I don't know what I was about to write, but now, you should know what a hypothesis is from your science classes, right? It's an educated guess, pretty much. Well, that's basically what we're doing here, except we're doing a little bit differently. Hypothesis testing in statistics is to evaluate claims about a population. So that's the goal. There's going to be a claim, and we are going to test that claim. That's what hypothesis testing is. Okay, so how do we start? Well, what we do is we start with a statement and its counterstatement. This is extremely important, and if you take nothing else out of this particular chapter, this is what you have to take out. Because if you get this next statement through your mind, it will make it a whole world of difference for everything else that we do in this semester in this class. Okay, so we're talking about something called the null hypothesis. The null hypothesis states there is no difference between a parameter and a point estimate. Okay, you should know what a point estimate is by now. So basically, what we're saying here is that if you're given a point estimate, if you find the mean of something, or if you find the standard deviation of something, or something like that, and there is a statement about that parameter, that there will be no difference between the mean or whatever the parameter, whatever the statistic you find is, and the actual parameter. We'll talk about more, but the big point about this, about null hypothesis, is no difference. No difference. Okay. Now, then we have the null, and then we have the alternative hypothesis. Okay. Well, if the null hypothesis says there is no difference, then guess what the alternative hypothesis would say? There is a difference. Now, for example, let's say that you say that, or you take a pulse rate of a whole bunch of people, and you find that with the pulse rate that mu is equal to 82. Our null hypothesis, or HO, would state that mu is 82. There is no difference between what you found for mu and what the actual mu is. Now, the alternative hypothesis for something like this would state that mu would be not equal to 82. It could be higher, it could be lower. It really depends on how the problem is stated, and that will tell you what we're looking for as far as your alternative and your null. Remember what I said, the null hypothesis always says there is no difference. That means your null hypothesis always has to have the equals in it. Must have equal to in null. Now, I know that doesn't make sense right now, but it will. Okay, especially when you start getting into problems. Okay, so let's do another example. Okay. Does a teaching method increase test scores? Does teaching method and okay, so now we're asking a question about something. Let's say that you found a mu of 78.2. Now, your null hypothesis would say that the teaching method either did not increase the test scores, or the test scores would have gone down. Okay, so what you would say is mu is less than or equal to 78.2. The alternative, the HI, would state that mu is greater than 78.2. HI can never have an equal sign in it. HI will always be less than, greater than, or not equal to. It will never have an equal sign in it necessarily. Okay. Now, let's take a look at one more. Let's say that you're given some sort of a diet, and you found that mu was equal to 187. Now, what do you want to do on a diet? Do you want to gain weight or do you want to lose weight? You want to lose weight, right? So, what's going to happen is you're going to say your null, if this diet works, would be that mu becomes greater than or equal to 187. Again, the equal to has to be there. Your alternative hypothesis, HI, would state that mu is less than 187. Now, when you had not equal to, okay, that indicated that you have a two-tailed test. Now, what do I mean by that? That means that you want to check both above and below, okay? So when you're doing, because basically you're going to end up doing a confidence interval for these things, okay? So you want to check above and below the mu a certain amount. When you had greater than by itself in HI, this is all for HI, when you had greater than by itself, then that was a one-tailed test. and it was right-tailed. Trust me, guys, all this will make a lot more sense when we go through it. And then the last one that we just talked about with the diet, when we had the less than symbol, that also is a one-tailed test. But as you can imagine, that would be left-tailed. Okay. So what we're going to be doing with hypothesis testing is we're going to figure out how far off is X bar, and then we have to say, is it significant? Now, our decision on if it's significant can be one of two things. It can be either right or it can be wrong. So, decision about significance is either right or wrong. I think that kind of makes sense. You either make a right decision or you make a wrong decision. Now, there are two types of errors that can be made, okay? And we're going to spend a little bit of time on this today because this is something that you really need to understand, okay? And I think I'm going to show you an example that really makes a lot of sense, okay? So, our two types of errors okay? There are type 1 and that happens when you reject the null when it is true. Okay. Then there's type 2. And that is fail to reject the null when it is false. Okay, so let's do a little bit more with this, okay? So, let's say that someone is on trial, okay? And we have a null hypothesis. We have HO that says defendant is innocent. Then what would the alternative hypothesis be, HI? Well, that's pretty straightforward. That would be the defendant is what? It is not innocent. Okay, so I'm going to do a little box here. Okay. And we're going to put all the possibilities here. HO true. HO false, reject HO, convict, and then do not reject, and then that would be to acquit. Okay, so let's say the defendant is true. Let's say the HO is true, but we reject HO and we convict them. Okay, so what have we done? We have rejected a true null hypothesis. Okay, we've rejected a null when it is true, so that is a type 1 error. We sent an innocent person to jail. How could we? Now, let's say that HO is false. That means the defendant is not innocent, and we convicted them. Did we do anything wrong? No. That's correct. So that is a correct decision. So that's not an error, is it? The dude's guilty, and we said so, so we convicted him. Okay? Well, let's say that let's go back to HO being true, and we acquit them. Well, is that the right thing to do? If they're innocent and they're acquitted, yes, that's correct. That is another correct decision. Now, what about if HO is false and we acquitted them? Well, the defendant is not guilty, but we said that they were guilty, that they were innocent. So what is that? Well, we didn't say they were innocent, we just acquitted them. So what does that mean? That is a type 2 error, because we just did what? We set a guilty person free. So a type 1 error is putting an innocent person in jail, and a type 2 error is acquitting a guilty person. Do you see the difference between the two of them? I hope you do. Okay. So those are two types of errors that can be made with the non-alternative hypothesis. Now what we need to talk about is a level of significance. And the level of significance is our alpha. Okay? So alpha equals the probability of a type 1 error. And remember, that's convicting someone when they are innocent. That's just the same idea. Rejecting a null when it's true. And then there is another type of probability, and that's beta. And that's the probability of a type 2 error. Now, a common mistake that students make is thinking that, well, then alpha plus beta has to equal 1. No, it doesn't. There are 4 different possible outcomes, right? Only 2 of them have errors. So alpha and beta, they don't have to add up to anything, okay? And they certainly are not 1. Okay. So alpha is also the alpha that you are familiar with, all right? So if we have a one-tail test, okay, we're going to do some drawings here, because I know you all love to do them. Not. All right, so let's say that alpha equals 0.1, okay? Then if we're doing a one-tail test, and this happens to be a right tail test. We have 0.1 here. So that means that this is going to be 0.49, and the area under this half of the curve obviously is 0.50, because remember the entire thing has to be 1.0. And this is a one-tail test. It could be right, it could be left. Now the difference between that and a two-tail test means that we want, and if we still want alpha of 0.1, we're going to, and since we're checking both sides, we want a total alpha of 0.1, so this is going to be 0.05, and this is going to be 0.05. Okay, and the area in this part of the curve is going to be 0.495, and this is going to be 0.495. And this is a two-tail test. This is where making those drawings comes in really handy, because it makes life a lot easier. Okay. Let's do a couple of examples of finding our critical values. Okay, and then that'll be it for today. Okay, so let's say that we have three different things. We're going to do, this is an example, we're going to do three different things. We have a left tail test, alpha equals 0.1. For part B, we're going to do a two-tail, alpha equals 0.02. And for part C, we're going to do right tail with alpha equal to 0.005. Okay, so what are we looking at? Well, one of the things is you're going to be going back to table A on your chart. So this is you're going to be finding z-scores, and you're going to be looking at the numbers. You're going to be finding z-scores. So these probabilities, these alphas, they're the numbers that you're going to be looking for on the chart. Okay. So for A, let's draw our picture just so that we know. We have a left tail test with alpha equals to 0.1. That means everything to the right of it is 0.9, right? Well, if alpha is 0.1, what I do is I look on my table, table A, and I look for the number that's closest to 0.1000. And again, we're looking at the four-digit numbers, not the z-scores. We'll get the z-score from the four-digit number. So if I look, the closest one is 0.1003. When I find that, then I look at what the z-score is. So that means my z-score for this particular problem is negative 1.28. Hopefully all of you see that. For part B, we have a two-tail test where alpha equals 0.02. So what are we going to do? We're going to draw this, and now we have two tails. So each of these tails has to cover half of that 0.02, so this is going to be 0.01, and this is going to be 0.01. And we're going to have 0.98 in between. Okay, so if I have a two-tail 0.01, so what am I going to look for? I am looking for the number that's closest to 0.0100. And I'm going to look at this side because that's what the table shows me. So let's find as close as we can to 0.0100. Okay? So let's see. 0.0100. I have 0.0102 and 0.0099. So it looks like 0.0099 wins. So 0.0099 The z-score that goes with that is negative 2.33. Okay, does that make sense to you all? Hope so. Now, that means that this is negative 2.33. Well, what's the z-score for this one? Remember, these are symmetric around the mean, so this would also be 2.33 on the positive side. All right, so you have two z-scores here. Right, now, one more. We have a right tail of 0.005. So let's draw our picture. .005. If this is 0.005, what do I have this way? Well, it's 1 minus 0.005, right? So what is 1 minus 0.005? That's 0.9950. Now, why would I care about that? Well, remember, these probabilities are in are all left-tailed. So what we want to do is, if we want to find 0.005 to the right, we want to subtract that and find their 0.9950. Remember, we did this before. Okay, so now let's find the number that's closest to 0.9950 on our table. So there's two of them. We've got 0.9949 and 0.9951. So we have a z-score of 2.5, 7, or 2.58. Well, what do we do there? Well, since it's right in between, we can do 2.575, or we can just take the higher number. Okay. Either one's fine. All right, so tomorrow you're going to get more practice with this, and that's it for today. All right, guys, have a good one.